Okay, hello everyone. This is Maha Assad. Today I'll be presenting our study entitled as the effect of anchor's inclination angle on the flexural enhancement of CFRP strengthened reinforced concrete beams. The outline of my presentation will start with an introduction, the research significance, experimental program, experimental results, analysis of results, and then conclusions. Now, we all know that the structures deteriorate over time. They need regular maintenance and repairs because there are dynamic changes due to load type and or its magnitude. The solution would be either to replace the structure, enlarge the sections, strengthen using steel plates, or strengthen using fiber reinforced polymer materials. Now, FRP materials, they have many advantages. They have high strength to weight ratios, they're non-corrosive, durable, they're easy to install, and they are versatile. There are many forms of the main problem related to fiber reinforced polymer materials is the detachment of the FRP from the concrete in a phenomenon we call debonding, or when the concrete cover separates, which we call delamination. This failure mode occurs due to stress concentrations at the interface between FRP and concrete. And generally, debonding occurs when 40% of the FRP strength is reached, only 40%. And that's why anchorage of the FRP laminates was proposed. Now, there are many types of anchorage. There are the FRP transverse shrouding, the mechanical fasteners, and the FRP splay anchors, which we used in our study. The FRP splay anchor consists of a dowel, which is the part that is inserted into the concrete, the fan, which is the part that is splayed on the sheet, CFRP sheet, and the key portion where the fan meets the dowel. There are many parameters that influence the FRP to concrete anchor joint, the number of anchors, distance between anchors, anchor diameter, anchor embedment depth, fanning angle, fan length, and the anchor's inclination angle. The anchor's inclination angle is the angle between the dowel that is inserted into the concrete and the horizontal. The significance of this research is that most of the available data on FRP anchors were obtained from testing small anchors. There is a lack of data in the literature for the real behavior of anchors in preventing the debonding or delamination during bending tests, and there is lack of guidelines to design the anchors in the current design codes of practice. Also, it is claimed that using a 45-degree angle for the anchor's dowel is better than 90-degree anchor, since the dowel contradicts the direction of the crack that causes the delamination, as we can see in the picture here. However, a 45-degree dowel angle has not been tested for flexure in the literature. It was tested only for shear. So this study aims to investigate the effect of using a 45-degree angle for the anchor and compare it to a 90-degree dowel angle. The experimental program consists of 5 reinforced concrete beams. All of them were strengthened with the CFRP sheet. The reinforcement consisted of 2 512, they were 2,000 millimeter length, and the reinforcement consisted of 2 512 rebars at the bottom and 2 5/8 rebars at the top. They were heavily reinforced in shear with 10 5 stirrups at 100 millimeter spacing. The cross section was 250 in depth and 200 millimeter in width. One of the specimens was left unanchored to act as a benchmark, and the other 4 specimens were anchored with different configurations. 2 of the specimens had anchors of 14 millimeter, and the other 2 had anchors of 20 millimeter. The dowel was either 40 or 14 or 20. So the tested specimens were the unanchored beam, the beam with 14 millimeter dowel at 90-degree angle, beam with 14 millimeter dowel at 45-degree angle, and beam two beams with 20 millimeter dowel at 90 and 45 degree angle. The test setup, like all beams were tested under 4-point bending test in a universal testing machine. They were simply supported, and LVDT was mounted at the midspan to measure the deflections. Also, FRP strain gauges were mounted on the FRP sheets at the middle, where the stresses are the maximum, to monitor the strains in the FRP sheet. Now, for the material properties, the grade of the concrete was 44 megapascal, and tests were done to ensure that the grade is as specified. The steel has a strength, a yield strength of about 560 megapascal, and the CFRP sheets consisted of high-strength carbon fiber, and the epoxy was VRAP 7770. Coming to the experimental results, the failure modes first. Now, the typical failure of strengthened unanchored beams is always delamination. So our unanchored beam failed by delamination. As we can see here, the concrete cover was separated from the rest of the beam. Now, the beam anchored with 14 millimeter at 90 degree angle failed by debonding plus anchor rupture, while the beam anchored at 45 degree angle failed by severe delamination, and it was abrupt, and the concrete cover separated like suddenly. The beams anchored with 20 millimeter diameter at 90 degree failed by delamination, and also the beam anchored at 45 degree angle failed by delamination. But here we can notice the difference between the two failure modes. The first one was like the concrete cover remained intact with the beam, but in the case of the inclined anchor, it was like totally separated, and it was severe delamination. Now, coming to the load deflection responses, a significant enhancement in the load deflection behavior is exhibited by the beams that has vertical anchors, that are anchored with vertical anchors A1490 and A2090. So we can here notice a percentage increase as compared to the unanchored beam of like 18% for the beam anchored with 14, and 40% for the beam anchored with 20 millimeter anchors. But we can see that the beams anchored with the inclined anchors, they did not improve the strength at all. In fact, their strength was even less than the unanchored beam. We also measured the strain in the CFRP laminates and plotted the load versus strain. And here we can notice that A1490 reached the maximum strain in the FRP laminates. We also calculated the strain utilization percentage, which is the percentage of the maximum strain attained in the CFRP laminate during the experiment to the rupture strain of the CFRP, and it is a measure of how much we utilized of the CFRP strain. So here we can notice that the maximum strain utilization was obtained by the beam anchored with 14 millimeter diameter at a 90 degree angle. So our conclusion is that the use of CFRP anchors at a vertical dowel delayed the delamination and improved the behavior of the beams at failure. The failure observed in specimens having inclined anchors was unfavorable. There was an abrupt separation in the concrete cover that was even more brittle than the unanchored beam. So using an inclined dowel angle in the anchored beams did not enhance the flexural capacity. In fact, the flexural capacity was even less than the unanchored beam. And also drilling inclined holes for larger diameter anchors in flexure is impractical, since there's high chance that the drill will be obstructed by a steel bar or a steel stirrup. Therefore, it's not recommended to use inclined anchors in strengthened reinforced concrete beams for flexure. That's it. Thank you for listening, and I'd be happy to hear any question.